Bismillah, this is Dr. Magda Talib Al-Hinai from the Department of Mathematics and Statistics, Sultan Qaboos University. We continue our discussion on matrices. This presentation is exclusive for the Independent Learning Center at Sultan Qaboos University. So we continue our discussion on matrices and we present here determinants. We define a determinant of a matrix to be a number associated with every square matrix. This number tells us whether the matrix has a multiplicative inverse or not. Next, we show how can we calculate this number. So here we start with determinants of 2 by 2 matrices. Find the determinant of the matrix A, which is in front of us, having the elements A11, A12, A21, A22. This matrix, I wrote the diagonal elements having its slope downwards to the right in red colors and the other diagonal elements in green color. In order to expand the determinant of A, I multiply the red elements and then I subtract from this product the product of the green elements. So I have A11, A22 minus A12 times A21. And I try to make an illustrative diagram for this. I put a red arrow having its slope downwards to the right, and then I write minus, and then a green arrow as we see in front of us. So we make it easy for us to calculate the determinant of a 2 by 2 matrix. This will be made clearer by the following example. Here we have an example. Evaluate the determinant of the matrix, which is a 2 by 2 matrix. I read the elements row by row, 2, 1, 5, 3. We apply the same rule we wrote in arrows. So we have the red diagonal elements, the 2 and 3. Their product will be minus the green diagonal elements, the 1 and 5. So 2 times 3 minus 1 times 5, this is equal to 6 minus 5. So this is 1, meaning that the determinant of the given matrix is equal to 1. Now, we present determinants of 3 by 3 matrices. Suppose we have the matrix A, which is in front of us, a 3 by 3 matrix. And we have the 9 elements of this matrix written row by row, A11, A12, A13. Second row, A21, A22, A23. Third row, A31, A32, A33. The place of these elements, the place, I'm talking about the place itself, is given a sign. We give it a plus for the first entry, which is A11. To the right of it, A12, its place is a minus sign. And then A13, its place has a plus sign. And so on. We go to the second row. So under the plus of A11, we put a minus. And then to the right of it, A22, we put a plus. And then A23 will have, after the plus comes a minus. So the plus minus keep alternating element by element for the 9 elements of this matrix. Now we want to expand the determinant of this matrix. It's given by the determinant of the matrix A is given in front of us by determinant A. So we start expanding by the first row, for instance. So I start by A11. I write it in red. Taking A11, if you look under this A11 in this line in front of us, we have a blue line cancelling the row and the column of A11. And we remain with the green elements A22, A23, A32, A33. So the first element here will be A11 multiplied by the determinant of a 2 by 2 matrix, which is written in green elements A22, A23, A32, A33. Next, we move to the second element in the first row. What's the sign of this place? Yes, it's a minus sign. So A12 will be preceded by a minus sign and then multiplied by the determinant of the matrix of the elements A21, A23, A31, A33, which are written in blue, meaning that we cancel the row of A12 and the column of A12 and we take the remaining elements to put them in the determinant. We move on. A13 Yes, this element has a positive sign for its place, and then I multiply it by the determinant of the remaining elements if I cancel the row and the column of A13, and these I give them the purple color. So we have A13 multiplied by the determinant of the purple elements A21, A22, A31, A32. Let's have an example to explain this. Example: find the determinant of the matrix A, which is a 3 by 3 matrix. I read it row by row. The first row 2, 1, 7. The second row 0, -1, 3. The third row 1, 8, 5. So we proceed again in the same way we did in the last slide. I take the first element, I cancel its row and its column, and I take multiplied by the determinant of the remaining elements written in red. So here we have the 2 in red. I cancel the row of the 2 and the column of the 2, and I'm left with -1, 3, 8, 5. And then I move to the 1, which is written in front of us in green, and I cancel the row of the 1 and the column of the 1, and I'm left with elements of a matrix which is 2 by 2, 0, 3, 1, 5. These are written in green. Finally, we move to the 7, which we will write in blue color, and I cancel the row of the 7. I cancel the column of the 7, and I'm left with the matrix elements for which I take the determinant. These elements are 0, -1, 1, 8. Now we have the sum of 3 colors, something written in red, minus something written in green, plus something written in blue in front of us. The 2 written in red, which is multiplied by the determinant, -1, 3, 8, 5. Now we expand this determinant. We expand it in the way we multiply -1 by 5 and then subtract from it the product of 3 and 8. So we have -5 minus 24 multiplied by 2. This will give us -58. Next, the -1 is multiplied by a 2 by 2 determinant. So the determinant of a 2 by 2 matrix. Here we expand this 2 by 2 determinant, which is written in green color. We multiply 0 by 5 minus 3 multiplied by 1. So this will give us -3, which is a +3. 7 multiplied by the determinant of a 2 by 2 matrix, which is 0, -1, 1, and 8. So we expand this 2 by 2 matrix, multiplying the diagonal elements. 0 times 8 minus 1 times 1. So this is 0 plus 1. 0 plus 1 is 1 times 7, we get 7. So here we have -58 plus 3 plus 7, this is -48. Now we move to define the inverse of a matrix. A square matrix A will have an inverse, a multiplicative inverse, if the determinant of A is not 0. And we denote the inverse of the square matrix A by A minus 1. This inverse matrix will satisfy the property that when I multiply it from the left or from the right by the matrix A, I get the identity element. Here we have the inverse of a 2 by 2 matrix. Suppose we have a matrix A, which is 2 by 2. I read it row by row. A11, A12, second row, A21, A22. The inverse of this matrix will be given by A minus 1 is equal to 1 over determinant A. So we need first to find the determinant of the matrix A. Make sure it's not 0 so that we don't divide by 0. Okay, now multiplied by the matrix. Look at the elements of the diagonal, which I wrote in blue and green. Switch the places of these two elements. So put the green in the place of the blue in the place of the green. So we will get A22. Instead of A12, just multiplied by a minus sign. And instead of A21, just multiplied by a minus sign. So we will have a matrix A22 minus A12. The second row is minus A21, A11. If I divide this matrix by the determinant of A, I get the inverse of A, which is A minus 1. Here comes an example to illustrate inverse of a 2 by 2 matrix. So find the inverse of the matrix A, which is a 2 by 2 matrix. I read it row by row. Row 1, 2, 1. The second row, 6, 4. So first we need to check that the determinant of A is not 0. So we need to get the determinant of matrix A, which is determinant of 2, 1, 6, 4. Again, we expand this determinant, multiplying the diagonal elements 2 by 4, subtracting from this product the product of 1 and 6. So this is equal to 8 minus 6, which is 2, which is not 0. Now we find the inverse A minus 1, which is equal to 1 over determinant A multiplied by the matrix. We switch the places of the 2 and the 4, so the 4 will come in the place of the 2 and the 2 will come in the place of the 4. And then we multiply the 1 and the 6, each we multiply by a minus sign, by minus 1. So here we have the inverse matrix to be half multiplied by a matrix, 4 minus 1 minus 6, 2. Now we multiply the whole matrix by half, so half times 4 is 2. Half times minus 1 is minus half. Half times minus 6 is minus 3. Half times 2 is 1. Now we need to check our answer, that the matrix which we got, and I read it row by row, 2 minus half minus 3 and 1. This is the matrix of A minus 1. We need to check if the product from the left and the product from the right by the matrix A will give us the identity or not. So simply we do A times A minus 1, we put the matrix A and we put the matrix A minus 1, and we perform matrix multiplication as we see in front of us, that this will give us a matrix which is the first row is 1, 0, the second row 0, 1, which is the identity matrix for a 2 by 2 square matrix. In a similar way, we can show that A minus 1 times A is equal to the identity matrix. And this we will leave for you as an exercise.